Alright, in this video we will explore the properties of similarity, and we will use those properties to find unknown sides and angles. Let's start off with a couple of word problems. We have a 6-foot tall man that casts a 4-foot long shadow. And if a nearby building casts a 54-foot shadow, how tall is the building? Alright, well, let's get a picture going. Okay, so we have a man, and he is casting a shadow. All right, so this will be his shadow. And that's going to form a triangle. All right, and then we have a building. And it is casting a shadow. And that's going to form a triangle. All right, now these two triangles will be similar. Now, the man is 6 feet tall, and his shadow is 4 feet long. The building shadow, we're supposed to find the height of the building, how tall is the building. So I'm going to put an X right here. I am going to consider the smaller shape here to be the old triangle, and I'm going to consider this larger one to be the new triangle. But it doesn't actually matter which one you consider to be old or new. What matters is that you start making fractions out of the corresponding sides. So, and we always make our proportions in the form new over old is equal to new over old. So looking at these corresponding sides, new over old gives me x over 6, and new over old gives me 54 over 4. I feel like reducing 54 over 4, so 54 over 4 gives me 27 over 2. So I have x over 6 is equal to 27 over 2, and now I'll cross multiply. So I will get 2x from that diagonal, and then 6 times 27. All right, 6 times 27, that's 162. And then I need to divide both sides by 2. So that's 81. All right, so that means that our building is 81 feet tall. All right, number 8, we have another shadow problem. James is 6 feet tall. When he stands 12 feet away from a flagpole, the tip of his 10-foot long shadow is in the same spot as the tip of the flagpole's shadow. How tall is the flagpole? So we are being asked to find the height of the flagpole, so I'll put an X right there. All right, so that forms two similar triangles, all right, this small red triangle and this large green triangle. I'm going to consider the small triangle as being the old triangle, and I'm going to consider the large triangle as being the new triangle. So keep that in mind when I set up my proportions by doing new over old equals new over old. So that's what I'm going to do right now. So looking at my corresponding sides here, the x and the 6 are corresponding sides of the triangles. So new over old gives me x over 6. Now, down here at the bottom, I have a bunch of numbers that I can use to do my corresponding sides. But be very careful. A common mistake is some students will write 12 over 10. and they'll be thinking new over old, 12 over 10. But that is wrong. 12 is not the side of the triangle. 12 is just this little leftover piece after the 10. All right, it goes from here to here. If I want the bottom side of the new triangle, I need to use both of these. So that's going to be 22. So when you do new over old, you must do 22 over 10, not 12 over 10. So that'll be 22 over 10. And then you can cross multiply. Well, actually, I like to reduce first. That's just me. So this would be 11 over 5. And now if I cross multiply, that's going to be 5x is equal to 66. And then if I divide both sides by 5, okay, so that's 66 divided by 5. That's 13.2. All right, so 13.2 feet will be the height of the flagpole. All right, in problem number 9, we are given a similarity statement. Let's use that to make sure that we can match up the corresponding sides properly. So, for example, we know that side AB should be corresponding to side ED. So here's AB, and here's ED. Those are corresponding sides. So I'll use circles. We know that side BC corresponds with side DC. So I'll put a square on BC, and I'll put a square on DC. See, if you were just guessing, you might have thought that the 24 and the 16 were corresponding. So you really had to use the similarity statement to see that BC corresponds with DC. The 24 goes with the 12, not the 16. Okay, that leaves the X, side AC here, the beginning and the end, to be corresponding with the side EC, which is the 16. All right, so I've used shapes to match up my corresponding sides. Okay, the most important pair that I just made is the pair that is all numbers. So you see that the 24 and the 12. So I'm going to use those twice to find X and then to find Y. I need to go ahead and decide which one of these will consider new and old. I usually will treat the small triangle as the old and the larger triangle as the new, but it doesn't really matter. But that's the way I'm going to do it. So when I do my proportions, I will always do new over old is equal to new over old. So I'm going to set up my first proportion. So new over old, that will be 24 over 12. So then if I want to find X, I need to match up the corresponding sides involving X. And I see that as X and 16. Remember, we're going to do new over old, so that'll be X over 16. Now, I would prefer to reduce this. So this is going to be X over 16. And this actually reduces all the way down to 2 over 1. Interesting. So if I cross multiply this, that's going to give me X is equal to 32. So X is equal to 32. All right. Now, when I go to find Y, let's match up the corresponding sides involving Y. That's the 6 and the 2y minus 7. Since I'm doing new over old, I'm going to do 6 over 2y minus 7. All right. Now for the other corresponding sides, I could use 12 and 24 again. But remember that reduces down to 2 over 1, so I'm just going to go straight to that. If I cross multiply, along this diagonal, I'm going to have 2 times 2y minus 7. And along this diagonal, I'm going to have 6. Don't forget to do the distributive property, so I have 4y minus 14 is equal to 6. Then I would add 14 to both sides, so that will give me 4y is equal to 20. So then I must divide both sides by 4, and that is going to give me y equals 5. So now I've got y equals 5. And last but not least, I need to find z. Let's see. Oh, z is an angle. I'm like, where is it? So when it comes to finding these angles, I see that angle D, if I could just highlight here, corresponds with angle B. So that's going to make this a little bit extra easy. Because angle B is 77. So I don't even need to subtract from 180 or anything. I just put down the 77. Number 10 looks like it's going to be about the same thing. All right. The letters are in a different order. Okay, fine. So AB corresponds with DE. Can you see that? Just looking at the similarity statement. AB corresponds with DE. So I'll put a circle around AB, and I'll put a circle around DE. Okay? And then I see that BC corresponds with EC. So BC, I'll put a box around that, corresponds with EC. I'll put a box around that. And that leaves AC to correspond with CD. All right, so notice, it's the same exact picture, but I'm going to get different answers. That just goes to emphasize to you that you have to use the similarity statement.
Oh.
So, once again, in order to set up these equations, I need to start by looking for the pair where I have both numbers. So the pair where I have both numbers is the 24 and the 16. Once again, I'm going to consider this to be new, and I will consider this to be old. Okay, so I'm going to, once again, I will have 24. Oh, but this time it's 24 over 16, yeah? Okay, so if I want to find x, I need to match up my corresponding sides involving x. So new over old will be x over 12 this time. So that's going to give me x over 12 equals. These are both divisible by 4, so this is going to be 6 over 4. Oh, you know what? They're both divisible by 8, actually. So this is going to be 3 over 2. And then I will cross multiply. So this will give me 2x from this diagonal is equal to 36 from this diagonal. If I divide both sides by 2, I'm going to get x equals 18. All right, so x is 18. Well, now I'm going to go after the value of y. So I need a fraction that involves y's. But check out the corresponding sides. I circled them. And I need to do new over old. So that's going to be 6 over 2y minus 7. So 2y minus 7. And then I need the other fraction. Look, I can use the same numbers as before. I can use 24 and 16 again. But I've already seen that that reduces down to 3 over 2. So I'm going to skip to 3 over 2. And then I'm going to cross multiply. So along this diagonal, I have to do 3 times 2y minus 7. Along this diagonal, I have 12. Then I do the distributive property, so that gives me 6y minus 21 is equal to 12. Add 21 to both sides, and that's going to give me 6y is equal to 33. And then I need to divide both sides by 6. So 33 divided by 6 is 11 over 2. All right, so I could put 11 over 2. Or if they want me to put it as a decimal, that would be 5.5. All right, so we'll just have to be very clear on the tests and quizzes whether I want a fraction or a decimal, but be able to give me either one I ask you for. So that just leaves z. I don't think I will need to do any calculations. Z is the measure of angle D. And as you can see, angle D corresponds with angle A. And angle A is 76. So that means angle D is 76, which means that Z is 76. For number 11, notice that I cannot use the mid-segment theorem. We learned a theorem that if we have a midpoint connector, that's called a mid-segment, it will be half of the parallel side. But this is not a mid-segment, and the reason why I know that is because this is 6 and this is 9. That means this point right here is not a midpoint. If it were, then these would be the same. So this is not a midpoint, so I cannot use the mid-segment theorem. Instead, I have to do the kind of stuff that we usually do. I have to do new over old equals new over old. All right, so I've got the red triangle on the inside, and then I've got this larger green triangle on the outside. I will consider the inner triangle to be old, and I will consider the large outer triangle to be new. So now I need some fractions, man. Let's see. New over old. Well, if I look at these numbers right here, the 18 and the z, those are actually corresponding sides. 18 is the new and z is the old. So that's one fraction that I'm going to have. It's going to be 18 over z. Okay, now I need another fraction of corresponding sides. And to get it, I'm going to have to use this side, because this is where all the numbers are. I'm afraid my green line is a little bit in the way. But remember, I need new over old using these numbers right here. Now, here's the most common mistake that I see. Some kids will try to do 6 over 9, and they'll be like, oh, look, new over old. Well, that would be wrong, wrong, wrong. Because 6 is not a side of a triangle. 6 is just this little piece. If I want the side of the large triangle, I need to add these together. 6 plus 9 is 15. So that's why I actually need to do 15 over 9. All right, instead of 6 over 9. 15 over 9 reduces. 15 over 9, that's 5 over 3. So I have 18 over z is equal to 5 over 3. And then I will cross multiply. So this is going to be 5z is equal to 54. And then if I divide both sides by 5, and so this won't go in evenly. So this tells me that z is going to be 54 over 5. Or if I want a decimal, I will do 54 divided by 5, and that's 10.8. All right, be prepared to give me either, just depending on what the directions say. Okay, now I need to go back and do y. Well, x. I think I'll do x next. So I can still do the 15 over 9. That part's not changing. That's the scale factor. So I'm still going to do 15 over 9. Now for the x, new over old, that'll just be 12 over x. All right, so again, that gives me 12 over x is equal to 5 over 3. And I cross multiply. So this will be 5x is equal to 36. And then I divide both sides by 5. So this does not reduce. So x is going to be 36 over 5, or 36 divided by 5, which is 7.2. All right, be prepared to give me either one. And last, that leaves angle y. But looking at the large triangle, I see I have 2 out of 3 angles. So of course, I know that the angles in a triangle have to add up to 180. So if I do 180 minus 88 minus 35, that leaves 57. So y should be 57. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.